Norman window. A Norman window contains a semicircle mounted on top of a rectangle. Suppose the perimeter of this Norman window is 30 feet. Let's take a look at the picture. We have a rectangle and then we have a semicircle mounted on top of a rectangle. And then the perimeter of this window is 30 feet. So that includes this and then plus the rectangle. Okay, and then what is not included? This piece is not included. So that's the perimeter. And then our job is to determine the radius of the semicircle and the length of the rectangle that maximize the area of this Norman window. Alright, so we have a semicircle. The radius of the semicircle is x and then the length of the rectangle is y. Okay, so first step is primary. So primary, we are trying to maximize the area, right? So what is the area of this Norman window? The area is, we have to find the area of the semicircle. The area of a full circle is pi times radius square, right? This is a full circle. Since we only have a semicircle, so we have to multiply by 1/2. And then for the rectangle, that is the length times width. The length is y, and then the width is x or 2x. The width is x plus x, that equals to 2x. So this is a width times length. So there you go. That is your primary. We are trying to maximize the area. So this primary is in terms of two variables, x and y. We have to get rid of one of them. So that's why we need a secondary function. The secondary function is using the perimeter. So what is the perimeter of this Norman window? So first of all, we will need to find the perimeter of the rectangle, which is what? Which is y plus y, right? And then plus x. So we have 2x and 2y. So that is 2x and then plus 2y. And once again, this do not count. So that's why we have 2 copies of x only. And then what about the half semicircle? So what is the radius of a full circle? I should say, what is the circumference of a full circle? The circumference of a full circle is pi times the diameter, right? The diameter is 2x. So we have a pi times 2x. So this is a full circle. Since we only have half of a full circle, then we multiply by 1/2. And then let's put y on one side. But before we do that, we have to plug in 30 to the perimeter. So we have 30 equals to 2x plus 2y. And then plus 1/2 times 2. That is just pi x, right? Pi x, so we to put y on one side, so we have 30 minus 2x minus pi x equals to 2y, and then divide both sides by 2. 30 minus 2x minus pi x divided by 2, that is equals to y, and then we will plug in the secondary to the primary. And then we rewrite the primary function as a of x, that is equals to 1/2 pi times x squared, and then plus 2x, and then y is the big fraction. Okay, let's not sure if we can squeeze in. So 30 minus 2x minus pi x divided by 2. Alrighty, so looks like the 2x, so these 2 can get rid of the denominator. Okay, let's write the primary right over here. So we have a of x, that is equals to 1/2 pi x squared, and then we get rid of the 2's, right? So the 2's got cancelled, and then in the meantime we will distribute the x. So we have a plus 30x, and then minus 2x squared, and then minus pi x squared. All right, and then are we done? Yep. So the primary function is right over there. That is area in terms of x. And then the next step is we will have to find the first derivative and then find the critical number. Okay, so moving on to step 4. So that is step 4. So we have to find derivative and critical number. Okay, a prime of x, so we bring the 2 down. So we have bring the 2 down, then we have a pi x, and then plus 30 minus 4x, and then bring the 2 down minus 2 pi x, and then we have to set that equals to 0. Why do we have to set that equals to 0? So let's say we have a parabola, and then you find the derivative, right? The derivative is about slope, so slope equals to 0 means you have a horizontal tangent. So let's say at this point, that is the maximum, right? At this point, there is a horizontal tangent line. So to find that point, we have to find the derivative of the parabola, set that equals to 0, and then we will get that critical number. And then once we prove increasing and decreasing slope, then we can show that that critical number is a maximum. So that's why we have to set that equals to 0. Equals to 0 means we have a horizontal tangent, and then we can solve for x. The x is the minimum or the maximum, depending on the function. So let's get rid of that. And then how do we solve for x? Can we simplify this? We have a pi x minus a 2 pi x. So pi x minus a 2 pi x, that is a 1 minus 2, that equals to -1. So we have a negative pi x, and then add 30 to it, and then minus 4x, we have that equals to 0. So let's keep the x on the left side, so minus pi x, and then minus 4x equals to -30, right? And then we can factor out the negative x. So factor out negative x, we have a pi minus 4 equals to -30. Multiply or divide both sides by -1, we have x times pi plus 4 equals to 30, right? So x is equals to 30 divided by pi plus 4. So this is your critical number. So this is your critical number. Is this an absolute maximum? We will have to prove it. So to prove it, I don't want to use the domain. I will just go straight to the second derivative test. So let's move on to the second derivative test. So I'm going to draw a line like that. So step 5 is to find the absolute max using second derivative test. Second derivative test. All right, and then double prime, so a double prime of x. So the pi x becomes a pi, right? The 30 becomes a 0, and then a minus 4, and then minus 2 pi. Do we have to set that equals to 0? No, but before I write the next line, let's make the 2 pi looks like a 2 pi. So all you have to do is you plug in 30 divided by pi over pi plus 4. So that is equals to pi minus 4 and then minus 2. Oh, you know what? There is no x, right? So this is only equals to minus 4 minus 2 pi. Is this a positive or negative? So this is a pi minus 2 pi, right? So pi minus 2 pi is negative pi minus 4. So that is a negative 3.14 minus 4. Of course, that is negative. That is always negative. So for the second derivative, it doesn't matter what number you plug in. The second derivative is always negative. Second derivative always negative means what? Means concave down. So concave. I should use a complete sentence. What is concave down? I should say the function a, the area function a is concave down when x is equals to 30 divided by pi over 4. So pi plus 4. And then what does that mean? So this is concave down, and then this is your critical number, and then there is a horizontal tangent line. So that means this is an absolute maximum, right? So there is an absolute maximum when x is equals to that quantity. Then what is y equal to? Then what is y equals to? So you have to plug it in right over here, right? Do you see this? So let's bring that down. So y is equals to, so y is equals to 30 minus 2 times x. So 2 times x. You know what? I'm going to take the 2 out. So like that. So we have 30 minus 2 times x, which is 30 divided by pi plus 4. And then minus pi times x. X is 30 divided by pi plus 4. Do not use approximation. Okay. So do not approximate x, do not approximate y. When you encounter this kind of situation on your homework, quizzes, and exam, you just have to go all the way to the end. Let's do it. So y is equals to 1/2. So we have a 30 minus a 60, right? Divided by pi plus 4, and then minus 30 pi divided by pi plus 4. And then what else can we do? Let's get a common denominator. So 1/2, and then the common denominator is pi plus 4. You have 30 times that, so that will be 30 pi. 30 times 4 is equals to 120, and then minus 60 minus 30 pi. So the pi is gone, and then you have 60 divided by pi over 4, right? So you have y equals to 1/2, and then 60 divided by pi plus 4. So get rid of take the 60 divided by 2, so y is equals to 30 divided by pi plus 4 as well. So this is your y, and then this is approximately equals to 4.2 feet. The 4.2 is just for yourself when you do homework online, unless they tell you to approximate. Otherwise, never approximate. So to answer this question, when x and y is equals to this 30 divided by pi plus 4, what is maximized? The area of the Norman window that we are talking about is maximized. Okay, so that is the end of this video. Do you like it? Is this helpful? If so, give me a like, share, and subscribe, and I will catch you all in the next lesson. Signing out.